So one other thing that we could do with these equations with fractions that will make them easier to deal with, especially if we don't have a calculator handy, is clearing the denominators. Because what that'll do is that'll turn the equation into a new equation that's free of the denominators. So this is really the preferred method to solve equations with fractions, especially when there's no calculator available. So what you do is, it's very simple. Clear the denominators by multiplying both sides of the equation by the least common denominator. And then what that'll do is it'll give you a much simpler equation where there's no more fraction operations to deal with, right? But the only trick to remember is you got to multiply each term by the LCD, whether or not it contains a fraction. So occasionally you'll get terms that don't have fractions, but they still need to be multiplied by the LCD, because it's the whole idea of balancing an equation, right? Everything has to be multiplied by whatever the LCD is, whether it has a fraction or not. So some of these, like this first one, and even that second one, kind of. Well, I guess not the second one, but the first one definitely. It's simple enough where you wouldn't even really have to multiply by the LCD. It's just a one-step equation. But assuming we wanted to clear the fractions from this equation, right? We'd look and we'd say, all right, our denominators are 3 and 5. So the LCD of 3 and 5 is actually going to be 15. So what you're going to want to do in this equation is multiply both sides and each term on each side by 15. So what you're basically doing is you're doing this. 15 times y minus 15 times 1/3 equals 15 times 4/5, right? So you have 15 times y, which is just 15y. Now over here, 15 over 3 reduces to 5, and then this is negative 5 times 1, so negative 5. And then over on the right, 15 over 5 is 3, and then 3 times 4 is 12. So now I have a much simpler equation to deal with, right? 15y minus 5 equals 12. No more fractions. So all I would do now is just solve this using my basic process. Add 5 on both sides, and then divide by 15 on both sides. So hopefully this was the same solution we got earlier, 17/15. Right? Does that match up with our other solution? Yep, 17/15. There it is. And like I say, in this case, really clearing the denominator resulted in, it taking longer to solve that equation. But in general, this is going to be the way you're going to want to do it when there's a lot of fractions involved. So this second one is the first one where definitely you'd probably want to remove the fractions. So if I have denominators of 2, 3, and 4, I would recognize that my LCD of 2, 3, and 4 is actually going to be 12. So what you do is you'd multiply each term here by 12. So you'd have 12 times 1/4 y minus 12 times 2/3 equals 12 times a half. Right? So I'm just putting a 12 by each term to show that I'm multiplying each term by 12. And now you do this cross-canceling business again, right? 12 over 4 is 3, and then 3 times 1y is just 3y. 12 over 3 is 4, and then 4 times 2 is 8, so that's minus 8. And this is equal to now 12 over 2 is 6, and then 6 times 1 is 6. So now I have, again, a much simpler equation to deal with, which now I can solve normally. Add 8 on both sides. 3y equals 14 and then divide both sides by 3. So I'll have y equals 14 thirds, right? So the general process when you're multiplying to clear the denominator is do the cross canceling and then multiply by whatever's left in the numerator by what you had. So I'll explain that again as I do this one, right? So y over 6 plus y over 4 equals negative 1. So here the LCD of 4 and 6 is 12 again. So I'd multiply each of these three terms by 12. So I have 12 times y over 6 plus 12 times y over 4 equals 12 times negative 1. And this is the first time that we've had a term that doesn't have a fraction, but just because it doesn't have a fraction doesn't mean that you don't have to multiply it, right? You still have to multiply it by the 12. So now here's what I was talking about before. When you're going to multiply to clear the denominator, 12 over 6, right? So you do this cross canceling first. This gives me 2. And then I multiply what's left here, the 2, by whatever was in the numerator originally. So 2 times y is just 2y. Same thing here. 12 over 4 is 3, and then 3 times y is 3y. And then here there's nothing to cross cancel because there's no denominator, so I just do 12 times negative 1, which is negative 12. And now you can see, as was when we did this in the other video, 2y plus 3y are like terms, and that's 5y equals negative 12. And now I would just divide by the coefficient, which is 5. So y equals negative 12 fifths. And there it is. All right. Now, this last one here is a little bit tricky because you have this 2/3 parenthesis x minus 2. So realistically, even though this isn't the most efficient way to do this problem, what I would recommend doing in this problem is first distributing the 2/3 before you clear the denominator. So what I would do is I would distribute the 2/3 first, which is what we did when we solved it the other way, right? The normal way. And then what I would do is, now I would say, all right, I have denominators of 2, 3, and 6. So the LCD of 2, 3, and 6 is 12 again. LCD is 12. So I'm going to multiply each of these 1, 2, 3, 4 terms by 12 now. So 12 times 2/3 x minus 12 times 4/3 plus 12 times 5/6 equals 12 times negative 1/2. And now, yes, right now it looks like a big hot mess. But what's going to happen is all this cross canceling is going to get rid of these denominators. So 12 over 3 leaves me with 4. And then 4 times 2x is 8x. 12 divided by 3 is 4. And then 4 times 4 is 16. 12 over 6 is 2. And then 2 times 5 is 10. And then 12 over 2 is 6. And then 6 times negative 1 is negative 6. Now what I do is I realize, hey, these are like terms on the same side. Combine those. Get 8x minus 6 equals negative 6. Get rid of this negative 6 by adding 6. And remember, when we did this the first time, the other method, we also had 0. Same idea. So here the negative 6 and the positive 6 cancel. We have 8x. Negative 6 and positive 6, yes, they cancel, but you still have to write the 0 there to hold that something on that side. And then you would divide both sides by 8. So we'd still have x equals 0. So that's the alternative method to solving equations with fractions, by eliminating the denominators by multiplying by the LCD. And yes, do they look messy? Sure, but once you get the hang of doing that, it's actually very easy and it makes the equation much simpler to solve, because you always end up with equations that no longer have fractions, right? Like in this case, we had this equation, which was much simpler to solve than that equation. So that's the idea.